Buenos dias, and hello to the international community who made the effort to come today for this huge and nice conference for developers and the tech community. My name is David Leconte. I am a solution engineer working at DataStax, a company which is well known for its contribution for a product perhaps you know as a developers, which is the NoSQL database Apache Cassandra. But today, the talk we are going to deliver is not effectively on NoSQL database. It is about something on the edge, clearly on the edge, which is how we can leverage a new era in machine learning by using generative AI, and from that, build in another way, in a new way, GenAI application. So of course, for the tech community, it's a new topic. Perhaps some of you may consider it's a new Hadoop with a kind of strange premises. Perhaps you may think that it's something that you need to jump into because it's clearly the thing that is going to make the future. In any way, today and during this talk, the aim we have is to share a point of view on what can be done to make GenAI a reality for enterprises so we can contribute to give better value to end users. So just perhaps a word about DataStax and Apache Cassandra, though, because I can understand some of you don't know us. But in fact, you do. Because if you are users of Apple products, of Netflix, if you drink coffees at Starbucks, you use our technology. At Apple, each app which starts with an I is working on an Apache Cassandra or DataStax product. And what we want to do is provide the expertise we have been able to deliver on the last 14 years on the NoSQL data sphere to the new era of the GenAI-based applications. But for that, we need to address some pains, some specific area of concerns when it comes to discovering a new technology as tech people, as enterprises who want to take a new edge in this competitive space. So we know, and perhaps you already know, that as soon as we start a new technology, looking ahead in terms of production readiness, it's a kind of wow, something big and hard. And GenAI doesn't escape to this type of rule at all. So how could we find a way from ideation to production to ease the pain to something which is quite important talking about GenAI? For some of you, now, GenAI is using ChatGPT to make some code in everyday life. Perhaps you are already working on some specific projects related to GenAI, but I guess and I bet that only few of you have had the luxury of experimenting going to production with GenAI for real end-user-oriented applications. So what do we have to be concerned about? Well, first, perhaps we need to reassess and explain what is the RAG mechanism. In reality, what we want to achieve is to take the intelligence of an LLM in its ability to provide, yes, smart answers and generation by adding the internal knowledge we have been acquired in companies so we can extend the knowledge of an LLM with internal knowledge. And then from that, being able to build powered apps based on a specific use case. And this is where RAG is coming to play. A pattern that is ready to have your internal knowledge made of many data objects, many data sources in your companies, and to be able to pass that as a context to an LLM. On this diagram, what you see is in fact leveraging a query you are going to ask to a GPT, let's say, and if the GPT has the answer on its public dataset on which it has been trained, it can directly answer back to the question and say done. However, if he hasn't the answer because of the reality of the world up to a certain point, for instance, for GPT-4, it is November 2023, he doesn't know the world after that. So each time you want to ask a question about something which is not in its public dataset training, or which is after his training period, he doesn't know. So the only way you have to extend this knowledge is by providing new information to it. And this way, you can have an application when you don't have the answer in the public trained dataset to go to look at some context on the knowledge base you have been added. So if he doesn't have the information, he's going to look in a vector database, which is going to store a specific nature of data, which is vectors. Is going to retrieve this information, summarize it, place it to another LLM, and send back the query back so we can have an accurate answer to the question, even if the LLM has the answer based on his training data. So with that comes a lot of challenges. First, because it's an entire pipeline to fulfill, from pre-processing, from the way we can interact with an LLM, meaning what type of prompt engineering we are doing, okay, and how we are enhancing through prompt engineering the way we are going to get more accuracy in the query we are going to get. Also, how are we to call the API of the LLM? Is it going to be from an inference model through an API, though, or for security purposes, do we have to do that locally? Do we have to have our LLM in our private infrastructure? Also, when we are using LLM, we are not using one LLM. And when we are doing a kind of pipelines with GenAI, in reality, we try to leverage what we call agentic operations. In fact, we can design entirely dynamic workflows that are going to leverage many patterns, many LLMs, and many ways of interacting with the data and the AI intelligence. And finally, we have to question ourselves on how we can leverage the pre-trained data from the LLM with the ability to fine-tune this information and intelligence to specific needs that can be coming on top and in addition to the RAG mechanism. So this is the main type of things you have to do when you think ahead in terms of designing a GenAI application. But when you ask to companies like big banks, what are their challenges? So they are asking clearly, well, how can we use mainly GenAI because we are in a regulatory market? And if we pass information to GPT, then we are going to lose the control on our data, okay? That's a big question. So it means that we cannot rely on the ability of the LLM providers to train the LLMs for us. We need to be in capabilities to add this knowledge ourselves to the LLM. The second aspect is we need technical support. And the issue is that in the GenAI data sphere or data ecosystem, most of the strong libraries now, period, are open source. In the name of LangChain, in the name of LLamaIndex. But imagine going in production with full open source technologies. We have been made to work independently, one from the other, and working on a strategic use case, only being able to leverage Stack Overflow. It's kind of hard, almost impossible. And finally, for those of you who have already played and used GPTs and the likes, what you are finding is that because of the non-deterministic nature of the LLM, you have change in behavior. You have data drifting effect. So over time, the quality of its answer is losing accuracy, is losing context, so at some point, it is unintelligible. We have a customer, an AI native customer called PhysicsValor. And PhysicsValor has a challenge. It's an edtech company with 1 million students, and they have to deal with the traditional issues with IOPS and latency and so on. And on top of that, the GenAI challenges for their production application, managing the chatbot for interaction with their customers, because they are a small startup, and they find smart to use the most as they can the chatbot mechanism by using GenAI. So for them, the question was about, okay, but how can this change in behavior? How can we deal with the fact that it's hard to manage the libraries effect of the GenAI ecosystem? And when we deep dive into that, it appears that because we are using, and customers who are building GenAI apps are using open source frameworks mainly, those frameworks are not working in sync together. You may have changes in the OpenAI API, and it will take some time before it got reflected into LangChain API. So you will start having a kind of dependency type of issue, and you will have to manage this dependency, and you have on top of that a kind of encapsulation of libraries. For instance, not all the libraries are just GenAI libraries. For some, by using some transformers, you will have to use Torch and PyTorch. And by using PyTorch, you will have to use also other types of embedded and encapsulated libraries. So the risk here and the difficulty is defining the correct equations of libraries, knowing their dependency and the way they are evolving in an asynchronous way. That's a big impact in the way we can start and secure our developments on one side, but also in the way we are going to be able to secure and de-risk the production as soon as we are going to go there. So that's a question. And also, we need to find a way to provide supported and support and very compliant type of approach to make the most of these jewels, which are these open source libraries. So we are stuck into two issues. We have the means, we have the tools, but as soon as we want to go to production, then we are in the middle of something that is preventing ourselves to go to. So what can we do? What can we do? But before answering these questions, I would like to effectively show you what can be this type of nightmare. So going to GenAI is effectively trying to expose yourself to managing this type of, and this amount of libraries and dependencies. So I'm just going to scroll and showing you the list of and dependencies which are at stake for a little type of application, which is not so. But when you do the pip tree, you see what it means in terms of number of libraries, category of them, and dependencies. And I can scroll this way for around 3 to 4 minutes. Yes, for me, it's a nightmare. So that's why at DataStax we thought about something very simple. Let's imagine we can provide a curated package of open source libraries we can support, we can monitor, so enterprises and developers can delegate to us the management of those libraries. And then, rather than having yourself to dig into and find the correct set of bundles and packages and modules you have to add, you have to maintain, you have to look for, placed with a dependency and what's time and money, just in your pip install, RAGStack.ai. This is a package DataStax has provided to the community that allows to work with a curated set of open source libraries that assembles the frameworks, LangChain, LLamaIndex, unstructured.io, Langflow, name it. And that allows to avoid the companies and the developers to go to this wasting place of money and efforts for nothing. This is not here there is a value. The value in the ability to build the application, not managing the libraries. So we decide to think ahead and say, okay, that needs to be the entry point of anything in terms of architecture you need to consider by implementing and designing your architecture. So RAGStack is a wrapper leveraging the main frameworks. And from that, we are going to align it with the other part of our technologies we are in control, in the name of Apache Cassandra, in the name of DataStax Enterprise Server, and the DB as a service in the cloud we have called AstraDB. So we can smoothline all the integration with the LLM and empower developers and companies to effectively go to production while implementing secured, accurate RAG applications. And we can do that with respecting a lot of requirements. So for our customer, what we wanted to provide is a way of effectively have a standard of libraries, of curated libraries, so we can support them, and so they can, and you can, as a developer, delegate to us the testing, the maintainability, the resolution around this integration of libraries, so you can focus on the real value of your work, of the user's requirements. Okay? So that's the key point here. So what does it mean? It means that DataStax every day is going to run some tests. And that's important because we are going to run tests that are about many types of equations of tests. And especially the ones we are tied to security. Because with GenAI, there is a new type of risks that is coming, which is, for instance, prompt injection. But you can also make cyber attacks through the libraries by themselves. Seriously, are you going to make every day, each time there is a change in API somewhere, OpenAI, LangChain, LLamaIndex, the proper security test on those changes and on those integration? Are you going to be able to effectively find the breaches? And if you are a bank, what are the impacts? So we are doing that for you. And as such, we are publicizing every day. And I will show first the type of test we are doing. Just through, you see the amount of tests we are going through. But the most important thing is that we publicize every day the results of this test with a score. And here, for instance, you may see that we have issues on one of the tests regarding the compatibility test. And we can see that we understand where the issue came from. It came from the ADA02 embedding model, along with the GPT-3.5 turbo, and the way to measure the data drifting and the accuracy of your GenAI app with Brilliance. So from here, what is going to happen is that DataStax will work with these guys to work on the solution. So you don't have to manage the libraries. You don't have to perform and update the type of tests that are required to keep the tests accurate and secured. And you are delegating to us the ability to solve the issue. That's huge. And you have support on using open source libraries. So that's concrete, that's pragmatic, that's TCO oriented, that's de-risk oriented as well. We are retrieving the risks and provide you easiness and professionalism in the way you can implement effectively GenAI applications. Well, so it's not just a way of saying, yes, DataStax, we are the best, and we have identified and done what nobody yet have done, period. But the reality is that in this GenAI world, even people like Leconte, who is the founder of LangChain, is using our product to test his own. So as you can see, the impacts of this type of approach around libraries management is something perhaps you haven't identified yet before today. But in reality, it's a key element of your move to production when you will be ready with a nice GenAI application. So here, everybody will win, because you as a developer, as architects, as business owner, you would be empowered to be able to focus on what is clearly important. For the stakeholders, all the risk management will be improved. So it means that we can make, in the reality, the go-to application in very, very strategic use cases, for very, very strategic use cases and complex ones. And also, being supported is a key for efficiency and de-risking of any enterprise-ready type of approach. So that's important because when enterprises look at that, they may take strong and weird decisions, knowing the current state of the art. We have seen some who have tried to fork open source projects like LangChain. So imagine the degree of dependencies they are placing and complexities they are introducing in doing that. We want to remove the technical depth of that because keeping agility on that is key, so you can still have the ability to integrate innovations as it goes. And on GenAI, it's a day-to-day blast we are having now. So you cannot find and implement things that are going to slow down you in the future. And finally, it's a way of being less dependent from the big guns like OpenAI, even though behind the scene we can leverage and integrate with them. So to implement that, it's just a simple pip install, and you can start doing your developments by using a kind of you would have the choice also in the frameworks you are going to use, LangChain, LLamaIndex, and so. And you will be able to reuse all of that up to the production. Okay? But at this stage, I have been talking about open source libraries, not yet databases. But the title of this talk is about using a vector store to boost your GenAI application, to provide a long-term memory so your knowledge base can be effectively stored and queried and indexed so you can use it in an efficient way for your GenAI application. But without starting from that, you won't get there. The question is how you integrate that with all the layers which are required to make your application solid. Hence, the vector store has to reflect that. And again, we thought about something in terms of integration effectively regarding the DB as a service and the managed service for sake. So we have a database for that called AstraDB. And AstraDB introduced a way of providing more accuracy when it comes to GenAI application. Can be counterintuitive, can be a kind of a discovery, but using a database, a vector store, has a direct impact on the accuracy you will have on GenAI application. So we have integrated the RAGStack with AstraDB, so you can get the value and the experience of DataStax applied to a vector store without losing anything coming from RAGStack. So here, it's a kind of golden. So just to mention that when you are doing a vector store, when you want to use a database as a vector store, in fact, do you want only to use a vector store for a vectorization, to store the vectors, your data vectorized? Well, perhaps yes, perhaps no. But one question will arise is, how are you going to shrink the process which is before the storage of your vectors? And how are you going to handle that, knowing that knowledge bases are not only based on batch data? You can deal and update your knowledge base with real-time data. So you are going to insert, update, upsert your data, and you will have to update, delete your vector if you want to keep accuracy in the way you are going to retrieve information from the vector. So you need a way to embed in real time in a way that can mirror how your data are inserted, updated, and deleted. So the pre-processing part of that is very important. And the question could be, do we need to delegate and externalize this pre-processing mechanism, or could we do it within the database? And for that, we think ahead also something by partnering with NVIDIA, and we embark their services into the database. So we can, in place, perform the pre-processing of your information. So this way we are simplifying the process and making a line from a performance perspective so the embedding mechanism can follow the flow of your real-time insertion, updates, and deletion. So, okay, there is this diagram, but perhaps I can show you an example. So on the left side, you will see a flow of information. It's just vessels from Star Wars, but just to have the grasp here. And what we do with DataStax and the impact it has on the speed of embeddings compared to another approach through APIs of calling the embeddings for the pre-processing stages. So here's how it works. So as you can see, the flow of information which is vectorized goes quicker with our solution based with compared to the right side, where it's very slow compared to the other. But what will be interesting is that here the latest embedding was done at 24 seconds, but look at which seconds the latest embedding will be done if you don't use an in-place embedding approach. Almost the double. Yeah. okay? And of course, this is simple information. The more complex the data objects, the more impactful this type of approach and architecture is. Okay, so we have seen the importance of having a delegation of the library management for GenAI frameworks with RAGStack. We see the importance of being able to have an architecture that allows inline and in-place vectorization of the information, especially for real-time and complex type of data. Is there anything we can do? Yes, we can. Especially when we think from the inception, from the root of the success, which starts at the talks with the business owners, the way we are doing the brainstorming sessions, the workshop sessions around how we define the requirements. And for that is being able to reuse everything we said in a graphic GUI. We can drag and drop pieces, design as we think, in a WYSIWYG approach. What we see was we get, okay? And ultimately being able to reuse this code to optimize it and effectively build the application. So from that, we decided to buy a company called Langflow, which is at its origin an open source company. And what we did with Langflow is just given the users and the developers the ability to design in a live motion way an entire pipeline. Langflow is nowadays a wrapper around mainly LangChain, but it will be extended to LLamaIndex and others. So you can graphically reuse everything we have just said by building something where live in push button, you'll be able to share with your business owners during workshops what you understood, if the express is clearly covered, and perform the correct adjustments. And from that, get the code, add to it, enrich it, and deploy. So, and this fact is everything is part of RAGStack. So what we wanted to share with you today is the fact that DataStax is a key player in the GenAI space, especially to implement the RAG mechanism that empowers companies with a new generation of application. We have a strong experience with more than 7 enterprises in production nowadays. We can handle billions of vectors with huge dimensionalities, and we are working with low latency, high availability, linear scalability, and more than ever, when it comes to GenAI, with far better accuracy. And part of this accuracy is coming from the way we are dealing with the data into our vector store. But on top of that, we have added toolkits to a specific ecosystem that is rising to ensure that we can effectively make GenAI application a reality. RAGStack is part of the play, and thinking in terms of volume, high-ups, business realities, dealing with the pre-processing motion through the input is also key. So I would like to thank you for your attendance, listening to me. I hope you learned something today, and I would like to wish you a very nice day, getting the most of this conference. So thank you.